Hello students, we are in section 5 of Numpy video tutorial where we're going to practice array related functions in Numpy package and array oriented programming. So there is a method called U function, that is the function U function actually a set of function that performs element wise operation in array. So far we have seen how to access array, how to change it, throw, swap it, transpose it. So everything is array-wise. So how to perform element-wise operation? Okay, change the values, access the each element of an array and change the values. Okay, so that's what we are going to practice in this video tutorial. So there are a lot of element-wise operations are available. Maybe we'll practice few. Let's create an array with range 10 by using the range function. Okay, and then let's see one method which is very useful, square root function. It's normal mathematical operation, but we are, instead of using math, we are using it through the Numpy package. Okay, so we are passing this array as a value to this, and you can see it will create a square root values of this. Square root of 0 is 0, square root of 1 is 1, square root of 2 is 1.414. Okay, that is square root function. Next, we'll see how exponential function will work. EXP. Even you can just, when you type tab, you can see exponential function. Okay, when you pass an array to an exponential function, what will happen? The exponential value with the base 10 that will appear. And Numpy has like a math. Numpy math has maximum max and ultimate max, different kind of functions like that. What is the difference between these functions? First, let's see the maximum function, then we'll see max and other functions. Maximum function, what it will do, it will compute the element wise maximum. It will just do the comparison in element wise and just will give the maximum of the given elements in terms of array. Okay, not for example, let's see, we are creating two arrays. Here we're creating two arrays with B and C. Okay, now we want to do some comparison of the values of these two arrays. For that, we can use the maximum. So tab, that will help you to pick maximum. So if you pick maximum and pass these B and C, these arrays as a value inside this maximum method, you can see it will do the element-wise comparison, not the row. In this 0 index, 4 is bigger. In the first index, 6 is bigger. In the second index, 9 is bigger. Like that, it will do the element-wise comparison. I'll show you one more example with random number creation. Okay, I'm just going to create 3 random numbers here. And then here we know the values. We'll do the same thing with random number for 3 array comparison. So np dot select maximum. And we are going to do the comparison among these 3 arrays. So x, y, g, you can see. And then you can see how it picks the random. Well, I didn't print the random, the 8 arrays. But it just picked the maximum values in each indexes. Okay, so next we'll try one more with the random integer package. Okay, we're going to call random integer with in 1 to 100 with the values 30. Okay, from 30 to 100, it will select some values. Okay, so you can see from 1 to 100, it will pick some 30 values. That's what the array will, with these 3 parameters will do. Between 1 to 100, it will select some 30 values randomly. Okay, now let's reshape this function. Function by applying let's create new, okay, with 25 values. So between 1 to 100, it will pick 25 values because I want that 5 cross 5 array. So we'll reshape it to 5 cross 5. And then let's see how it looks. Okay. now we are going to apply the max function of that. What the max will do, maximum will compare, I'll do the element-wise comparison and give the biggest element in each row. Do the element-wise comparison in each column. Okay. And what the max will do, it will just do the comparison for the whole array and will pick the maximum value. Okay. For example, I'm going to print the maximum of A. Maximum of M. You can see in the given value, which is the maximum value here. 98. Do you see 98 here, which is the maximum value? So do you understand? And the difference, the maximum will do the element-wise comparison between the columns, and the max will do the total comparison, which is the maximum value in the given value. So maybe I'll do one more example. Okay, I have created one more array. And then what I'm going to do, I'm just going to do argument max. What is the argument max? That is the third method that we are going to see. Argument max, what it will do, it will just do the axis-wise comparison. Okay, for example, in the same M, let's print the M first. Okay, we have this M value. So here we are going to find the argument max. We are going to apply the m.argmax function. Maximum of M location. Okay, so this is this value. Let's say when you pass the axis, how it will react. So with the axis value 1, when you pass this, so what it will do, it will just pick the column here, axis 1 here, and then just we'll explain it with one more example so it will be a little bit more clear to you. So when you see the axis 0, so what this argument max function will do, it will just do the index-wise comparison. For example, if you look at this simple argument max function will give you the maximum value. Okay, maximum value here it is 11. But when you provide the axis, the axis 1 means it is column-wise comparison. Always axis 0 means row-wise comparison. So if you take the axis 1, it will do the comparison of this matrix, given array, in terms of column. If you look at the columns, you can see 3 columns. So look at the columns. In all these columns, which value is the maximum value? 3, 7, and 11. Column wise, what is the index for this? 0, 1, 2, 3. So you have to give 3. Here also the index is 3. Here also the index is 3. So it gives 3, 3, 3. When you pass axis 0, that is row-wise comparison. So it will just take everything in terms of row. What is the maximum value of value in this row? In the whole row-wise, 8. Okay. And then here, 9. And then in row-wise here, it is 10. And then here it is 11. Okay. So what is the index for this row? 0, 1, 2. So all 2s. The row-wise indexing is 2. So the argument function, argmax function will help you to get the indexing in terms of either column or row-wise by specifying the axis. So next we are going to see how we can use the mod f function. So mod f function is an inbuilt function in Python that returns the fractional and integer part of a number. The same thing we can use in Numpy as well. So the same, almost all the functions that we are looking here is there in Python. Same operation, same kind of functionality that can be done using Numpy as well. So here we are creating a random values with the random integer 7, and we are multiplying that with 5. Okay, let's see how this array looks like. You can see it looks like this. Okay, now we are going to apply the mod f function. Okay, we are going to apply the mod f function. Maybe I will just create a title. Mod f. Okay, so I'm going to specify, because mod function always give you the whole part and remainder part, right? The remainder and whole part can be saved by calling the mod function, mod f, and what is the input? The array is the input. Okay, and we are going to call that remainder and print the whole part. You can see it will print out the, okay, it will just print, the last one will get executed. Maybe I will use the print function to execute this. You can see the print value that gives the remainder values, and the whole number is printed here. Okay, so the mod function will help us to deal with the complex values, to separate the whole values with the remainder value. Okay, so next we are going to see what are the array-oriented programming concepts that we can do using Numpy. First, let's see mesh grid. It's a simple example where we wish to evaluate some linear algebra equations, kind of square root of x squared plus y squared. Let's deal with that. Let's create a grid values using array. Okay, so Numpy has a function called mesh grid function that will take two one-dimensional array and produce two-dimensional matrix corresponding to these x and y values. Okay, maybe let's first get the points, x and y points first. Okay, so these are what it will do from -5 to 5 with the values 0 to 0.1. It may produce around 1,000 values. Between -5 to +5 with the interval 0.01, it will produce 1,000 points. Okay, now we are going to use the mesh grid function. Okay, mesh grid function, and Numpy has a function called mesh grid function where we are passing the points here. That will be saved as x coordinate and y coordinates. So let's try to print what is there in x and what is there in y. See, 1,000 points in both x coordinate and y coordinate. Now we are going to pass this x coordinate and y coordinate using the square root function. Okay, z equal to np dot square root x s square exponential plus y s square. Okay, so you can see this is the z coordinate where we are passing that formula x squared y squared square root. Okay, so now it's really hard to complicate. This is a really complicated data with 1,000 number of elements. This is how the real world data will look like. Okay, moving forward, we will deal with big arrays like this. The only way to see how the data is, you can see it will not show you all the elements because it has 1,000 rows and 1,000 columns. So it is hard to visualize the things. For that, always we have to go for visualization library. We're going to learn a lot of visualization libraries in the upcoming chapters. But as of now, we'll practice a simple trick to plot these, to visualize these data points using matplotlib. Matplotlib is a popular visualization library. So where we are calling the particular package pyplot and we are importing it as PLT. Okay. So from matplotlib library, we are going to call some methods to visualize these data. So PLT dot IamShow is the method. You don't need to worry about the methods, all those. We are not going to learn a lot of visualization methods. We will say it in detail in the visualization chapter. Right now, just focus on how we are visualizing this complicated data Z by using matplotlib package. So CMap, the coordinate mapping, where we want gray mapping. Okay, CM dot gray color coloring, and then so maybe PLT dot, let's create a color bar for this. Let's see how it looks. can see the color bar. This one will create this 0 to 7 color bars. And see each 1,000 values between the 0 to 1,000 pixel values. This will give you the each and every pixel value starting from 0 to 1,000, 0 to 1,000. You can see this is how it randomly created. Even though we randomly created, you can see some patterns. You can see each and every pixel value is a pixel value for them. And the 1,000 points are just mapped as a picture here, image here. Okay. So if you learn image, if you know image processing, it is easy for you to understand. See, I'll explain it again. From 0 to 1,000 row coordinates and 0 to 1,000 y coordinates, column coordinates. The random pixel values have been kept here as a gray level. Okay, from the mapping 0 to 7, it is kept as a color value. So if you see, there is a pattern here, even though it is picked in randomly, you can see the pattern because this is the equation. This is the shape of the equation, square root of x squared plus y squared. Okay, you can see what will happen when you apply the random points with this equation. This is what will happen. Okay, and you can, there are a lot of other stuffs. You can add title, okay, by using the plot or title, but I don't need to worry. You don't need to worry much about that. We will see these things in detail later on. How to create plot, how to, all those stuffs, you will see it in detail in the visualization library, visualization chapters. Okay, you can add titles, you can add color bar, those kind of stuff. So we'll discuss these visualization techniques later in the separate chapter. Okay, now I'm moving on for the different set of operations. Conditional logic array operations. Conditional logic array operations. This is same kind of concept that we discussed with Boolean indexing, but this is conditional array. Okay, so first I'll create the title. So the Numpy has a var function, .var function, that is a vectorized version of the ternary expression. I hope you are familiar with the ternary operation. Yes or no. The first condition is true, means yes will be picked, or else no will be picked. That is called ternary operation. All the languages has ternary operation. So this is an array-wise ternary operation. That is for scalars, but we can do the same thing with the array, with the array, the vectors. Okay, so we have two arrays, x and y coordinate. Now we are going to apply the condition. What is the condition? So condition is equal to np dot array. This is again another array, Boolean indexing. Maybe I'll just this is Boolean values. Okay, I'm passing the Boolean value as a condition. Okay, now what will happen? So here we are going to create the third variable where the condition is yes if C else y. Can you relate it with the ternary operation? If yes, do x, pick x, or else pick y. Okay, so how we are getting the values using the for loop. Okay, x, y, c. We have given, this is temporary variables. Okay, and then here we use the zip function here. The zip function, what it will do, it will just pick the value and zip it and pass it through the. Okay, I will first show the result, then I'll show you. Okay, it's a bit complicated here. So you can look at this. We have three arrays, two are floating point and one is Boolean array. And x, if this is the ternary condition, this is the condition, and we are iterating through the loop. X, Y, C are temporary values, and then we are passing it. We are just zipping, compress all those things and passing it as an list values, but the three different list values. Okay, so what it will do, it will, for x it will pick x array, for y it will pick y array, for c it will pick conditional. Okay, for this you have to pass all these arrays as a zip through the zip, so that it will unzip the values through each iteration and pick the value. Okay, so here you can see true value. So 1.1, which is true. 1.1 is true. The second one, false. So the 1.2 is false, so it picks 2.2. And then true, so it picks 1.3. When it is true, pick X. When it is false, pick Y. That is the condition, right? If C condition is true, pick X or pick Y. So true, pick Y, X 1.1. False, pick Y 2.2. True, pick X 1.3. True, pick X 1.4. False, pick Y 2.5. So this is like a ternary operation, compressed version of ternary operation. So in this particular exercise, you are learning a lot of stuff. How to do the ternary operation in array, and also how you can use the zip function to iterate through the array, to iterate through the 3 different lists, okay, in a compressed way. So if you, it's like, that is the one thing about Python. You can just write a compressed coding in one line. You can even write it in 3-4 lines, but even you can write it in one single statement, okay. If you're familiar with the programming, Python programming, you can reduce the codings. Okay, now we are going to see apply var function to do the same thing. Okay, we can do the same thing with our result np dot var, where we are going to pass this condition and then x array, XOR, and then y array. Okay, so let's print the result. So you can see the same thing. This is even more compressed. This full line of code, you can do the full operation using the var function. With simple coding, you can see the efficiency of using Numpy here, right? So this whole, it is already a compressed code. You can expand it to some 15 lines code, but still you can compress it in one function. Var function will do all the things that you have done using this complex statement. Okay, so that is the power of the packages. That's why we are learning. We are going to learn all the packages in detail. Okay, so you don't need to go for the complex coding. Instead, you can pick the appropriate methods, which has been written by someone already. Okay, so when they return this var function, they have written it in this way. So you don't need to code like this. You can simply call the var function. Okay, let's do some more using this var function. Let's create a random variable with 4x4 floating point number with 4x4 size. And what are we going to do? We are going to replace all the values, positive values with 2, and all the negative values with -2. How can we say this? Var, you can use the var method to do this. We can say for the given array, for all the values, when this condition is true, do this. When this condition is false, do -2. Simple. So you can see, or positive minus value. If you have to write the detailed coding for that, then you have to do something like this. But we can do it in a very simple way using this. Let's do one more to make it more familiar to you. Var np.var. We're going to say array the same condition, but this time you want to change all the positive values to 2. But if it is negative value, keep the values as it is. You can see, if it is negative, the negative value of the original array has been kept. Okay, so that is about logical array operation. Next, we are going to see some mathematical and statistical methods available in Numpy. So we're going to see set of statistical methods available in Numpy, okay, to handle statistical related operations, basic operations. But actually, there are a lot of separate libraries, particularly designed for handling statistical operations. That is kind of advanced. We may not cover it in this course, but we are going to see some basic statistical methods available in Numpy. Okay, it provides a wide variety of statistical kind of basic functions like finding out the summation, mean, standard deviation. Those kind of operations are very important when it comes to pre-processing of the data. Okay, so let's see how to use those functions. Let's create a simple array here. Okay, and random summation for. Okay, let's create this array. Maybe I'll bring it top. Okay, so let's create the simple array and let's see how it looks like. Okay, and let's call the mean function. Right? Simply you can call it mean function because this is created by using Numpy package. It should be able to compare, get the mean values of all the given array. Okay, and then similarly you can get this summation value of the given array. Summation that will get the summation of all the values with all plus minus. If you do the summation, this is the result. You can even do the axis wise comparison. Okay, you can do the column wise. If you want to do the comparison in the terms of column, then you can do by mean and pass axis value. If it is for column, then it is 1, right? So axis wise comparison. Run it. So you can see in terms of axis, all column wise comparison. It will just in terms of axis, what is the mean value for all the rows? 0, what is the mean value? What is the mean value for the first row, second row, third index, fourth index, like that? It will give all the values. Okay, so we'll do the same kind for summation in terms of summation along x-axis. X-axis means axis value 0. Okay, 0, 1, 2, 3, 4 values. Okay, it will just find the summation of column wise, 0 columns, first column, second column, everything. So cumulation summation provide cumulative summation. Okay, so cumulative summation. Array dot sum cumulative summation. See, I have just picked integer because you can, if you don't know what is cumulative summation, 0, 0, 0, 0, 1, 1 value, 0, 1 and 2 will give you 3. Then 1, 0, 1, 3, 1 plus 3 plus 3, that will give you 6. 6 plus 4, 10. Like that, it is a fact, like a factorial. It's a cumulative summation. Okay, so this is one-dimensional cumulative summation. Let's do it in the multi-dimension. Okay, multi-dimensional cumulative summation. Yes, I have created 2-dimensional array. Let's see how it looks. It looks like this. Okay, now I'm going to do the cumulative summation over axis 0, that is row-wise comparison. Okay, how can we do that? Right, array dot comes some cumulative summation axis equal to 0. Okay, so in terms of, oh, it doesn't give, supposed to give values. Okay, yeah, so now it gives 0, 1, 2. You can see 0, 3 plus 3. In terms of column, in terms of row, it just do the cumulative summation. Let's do the same thing for column. For that, you have to give axis value equal to 1. You can see for the column wise, 1 plus 3, and then 3 plus 5, 7, 7 plus 5, 12, like that. Okay, so this is column wise comparison. If you want to, I have given in the PDF, I have given the link for more statistical function. Maybe I will post the link here. You can refer the PDF. Okay, so this numpy.docs table reference routine statistical HTML, that will help you to explore more statistical related functions like this. It is one or statistics, average, variance, correlating, histogram. There are set of lot of useful functions available in NumPy that you can refer. Okay, next we are going to see how to what are the methods are available in NumPy for handling the Boolean array. Okay, Boolean values are, as we already see, either 1 for true and 0 for false. Okay, with the preceding methods. Sum is often used as mean of counting values. That is, if it is 0, maybe I will just share with some examples. I'm just going to create an array, okay, random array. And what I'm doing, I'm going to do some conditioning. When array value is 0, maybe first I will print out the array to see how it looks. Okay, so some floating point value. Okay, what I'm going to do now, array value, when it is greater than 0, when it is greater than 0, then do the summation, else don't do the summation. We can give some such conditions. Okay, so when it is greater, it will just ignore the negative value. When it is positive value, then it will do the summation. This is a very important, very leave the summation thing, but if you pick this itself, you can do this for many pre-process. For example, you're taking a EEG reading, and in some reading you get some negligible values, 0.00. You want to ignore those values, then you can give it as a condition. When the value is below this value, just ignore it. Like that, you can just give the conditioning. Okay, in that aspect, it is really useful. Okay, maybe I will give you one more example where Boolean array with some Boolean values. Okay, and then here I'm going to apply some other methods, which is so useful. Or any. So what it will do? Is there anything true? Then it will say true. Okay, then there is a method called or, which is like and. Everything should be true. So bools dot all. So which wants all the values to be true? No, we have only one value true. So it is like simply or, and this is simply like logical and. Logical and, this is like logical or. Okay. Those are some Boolean related operations. Next, we are going to see how to do the how to sort the arrays. Okay, how to do the sorting. Okay, so Numpy array can be sorted in place with sort method. The top level method that simply calling the sort function will return the sorted copy of array instead of the copy. It will just work on the copy. Okay, instead of working on the same array. Let's create an array, integer array. Let's type it. Let's print it. So some floating point. If you apply the sort method on this array dot sort, this is what will happen. It will just sort it with the. Do that in original array. So I'm just calling the original array, but still it does the sorting. Okay, it just works on the original array itself. Perform the sorting in the original array itself. Let's do some two-dimensional array thing. Okay, how can you create two-dimensional random integer 5x3? That is 5 rows and 3 columns. And I'm going to print it to see how it looks like. Okay, now I'm going to apply the sorting on this. Array dot sort function. Okay, now I'm going to call the original array, and you can see it will sort it out. Minus, then -2, -0, -1. Okay, it will do that sorting of values. Sorting of values. This normal sorting. Similarly, you can do the column-wise or row-wise sorting. If you do the 0, then it will perform the row-wise sorting. Then row-wise, it will just pick all the values. Similarly, you can do the column-wise sorting. Sort one index and pick the array, and you can see in column-wise 2.43 and 0.43. Okay, you can see column-wise, it just put it in the ascending order. This column-wise sorting. Okay, next we're going to see some other set-related logic operation. Set-related logic operation. Okay, I think that is, we're almost done with this video tutorial. After this, we're going to see some file-related operation, then we'll be done. Okay, so Numpy has some basic set-related operations, particularly for one-dimensional data. When you need to deal with the multi-dimensional data, pandas will be the best option. The very popular set-related operation is unique. okay, which return the sorted unique values. So unique is the popular set related operation. We will create, we have already created this names array. Let's use that. Okay, here we are going to apply the unique function. np dot tab. You can see unique function is that. I'm going to call the function and I'm going to pass this names inside. And you can see what are the unique values. It is like a tuple set. It is like a set here. You know the set data type, right? What is set? Set will just handle the unique values, right? So here there are a lot of repetition, but it will just ignore the repetition and just pick the repeated value. And we can apply the sorted on this. Okay, we can even call, there is a method called sorted method where you have to call the set and call the names. So this is that will make the set data type, that it will just pick unique value, and the sorted method will just display it in the sorted B and W in the ascending alphabetical order. Okay, let's do the same thing in integer. Let's create an integer. Okay. Then I'm going to call unique method, and I'm going to call this ints, pass this ints. And you can see it will just avoid the repetition and pick the unique value. Okay, this is set field. Set is the data type. If you recall, set is the data type that will hold only the unique value. So here with array concept, you can do the same thing by calling the unique function. You can make it like a set data type. Okay, next we are going to see file input output operation with array, file related operation. So this is the last content of the section 5. Okay, so Numpy has a very important package, a method called save and load method, because that's where everything is getting started. You're not going to this one, whatever the example that I have given with the random library, random functions, that is just for academic, for learning purpose. When you work in real world environment, you're going to import some file and export the file. So it is important to be familiar with the save and load function to import and export the data. So Numpy has save and load method. It's like, it is very efficient methods to handle to loading the file or exporting the file, importing and exporting the file. It also has the compression methods available to compress the files. Okay, let's see one by one. First, I'm going to create an array with the range function of 10 values. Okay, I'm going to save this. I have saved this. Okay, sum array and with the name sum array 1. Maybe sum array 1. I have saved it with sum array 1. And then I'm going to the file path does not already then already there in that. It will just save it as save the file, but how it will be saved as a numpy file. To save it as a numpy file, you have to use that. When you save it, it will be saved as numpy file. It will show you where it is saved in my folder. Analytics programming chapter 4. You can see sum array 1.numpy. So when I save it, when I use the save function, that will save it as a npy file. So when I have to load that, you have to use the load function to load the file, and you cannot just give sum array 1. You have to give npy because it is a numpy package. It's a numpy file. npy, np and the y. Okay, so that will load the function and see whatever is there inside the file that will get retrieved. Okay, even you can use the npg, archive the file. When instead of giving save, if you give save z, then it will just zip the file. Okay, so this is a very simple example, but when you work with a very big data file with a large amount of data, you may need to compress your file. For that, you have to use save z. Going to use save z. That will create the sum. It will create achieved zipped file. So for that, I have to give npz. Okay, I have to give keywords. Okay, so let me save this and see what's saved here. You can see a zip file has been created, npz. This is the zip file that has been created because of the save z. If I have to load it, then again I can use a handler, file handler for this, np dot load, and then I have to pass this. Okay. Just handle with the B handler, I can just pick all the values. So it will just B has all the values, right? So I can just pick the values, what is there in the file that can be done by passing it through the file handler here. Okay. That's about the file operation. You're going to see, you just learned save function to save the file, load function to read the file, save z to compress the file, to save it as a compressed file, and then how to retrieve the values, compressed file values using load function. Okay, that's what we have seen in the file operations. So if you recall in review what we have seen in section 5, how to use some element-wise array-related mathematical functions from Numpy package. Okay, like square root, exponential, modifier, mesh grid. What is mesh grid? How we can use the mesh grid to create the huge number of data, and how we can use the visualization library to visualize the data when it is very big, and what are the statistical method, popular statistical method that we can use from Numpy package, and then how to do the sorting, and how we can use the set logic operation in array, and then how to load the data and how to save the file, how to load and save the file using Numpy. Okay, thank you. In the next section 6 will be the last section of Numpy tutorial. See you in the next last tutorial. Okay, thank you.